Welcome to EDU World Space.
All right, let's take a look at this function g of x. G of x is equal to the definite integral from t equals 1 to t equals x of the function t squared dt. What does this mean? All right, first of all, this is going to be our t-axis since we have a function of t. Okay, x is just a number on the t-axis. It could be 2, 3, 5, -1. So x is just a number, but our variable is t. Okay, what does the function t squared look like? T squared looks like this. And when t is 1, t squared is 1. Okay, so this is the graph of t squared. Now, x is some number to the right of 1 on the t-axis. X is just a number. Now, the indefinite integral between 1 and x of t squared, that means we are finding the area underneath the t squared function between 1 and x. Okay, so the definite integral between 1 and some number x of t squared dt is the area underneath the t squared function between the numbers 1 and x. So this area in here, if I kind of shade it in, so the area underneath the t squared function between 1 and some number x is the value of this definite integral. Now g is a function of x. So what this is really meaning is g of x means the area underneath the t squared curve between 1 and some number x. So g of 2 means the area underneath the t squared function between 1 and 2. G of 3 means the area underneath the t squared curve between 1 and 3. So g is a function of x. Okay, g of x, the integral from 1 to x of t squared dt, is really the area underneath the t squared curve between the numbers 1 and the number x. Now, g of x is a function, and we can differentiate, we can find g prime of x. Using the fundamental theorem of calculus, if g of x equals the integral between 1 and x t squared dt, then g prime of x is simply the t function t squared evaluated at x. So g prime of x is simply the t squared function evaluated for t equal x. That's a fancy way of saying simply plug the x in for t squared. Instead of t squared, x squared. So if g of x is equal to the integral between 1 and x of t squared dt, the fundamental theorem of calculus says g prime of x will be, instead of t squared, x squared. Now, the other way they want us to find g prime of x is to actually calculate this definite integral. So down here, we're actually going to calculate the definite integral. So g of x, okay, so we're back to g of x. G of x is equal to the integral between 1 and x of t squared dt. So if you want to calculate a definite integral, we need to find the antiderivative of t squared. Okay, g of x is equal to the integral, definite integral from 1 to x of t squared dt. Well, the integral of t squared is t to the third over 3. And since this is a definite integral, we have to evaluate the t cubed over 3 between t equals x and t equals 1. So that simply means plug in x into this expression and then subtract 1 plugged into this expression. So t cubed over 3 when t is x cubed over 3. And then subtract, and then plugging in 1 for t, t cubed over 3 when t is 1 cubed over 3, or just 1 over 3. So that's our g of x function. G of x, okay, is the integral from 1 to x of t squared dt, but when we actually do that definite integral, we find out that g of x really is x cubed over 3 minus 1/3. Well, now we could find g prime of x simply by taking the derivative of this function. Since g of x equals x cubed over 3 minus 1/3, g prime of x will be the derivative of x cubed over 3 minus 1/3. Well, the derivative of x cubed is 3x squared. So the derivative of x cubed over 3 is 3x squared over 3 minus, and the derivative of a constant like 1/3 is 0. So 3x squared over 3, the 3's cancel, and we get just x squared. So take a look at what just happened. We found out that g prime of x is equal to x squared. Well, we already knew g prime of x was equal to x squared using the fundamental theorem of calculus, but now actually, calculating the definite integral, finding out the actual function for g of x, and then taking the derivative of it, we just found a second way of finding g prime of x. And of course, g prime of x is still g prime of x. So we would expect it to equal x squared both times. Even though we found it two different ways, it's still the same g prime of x, so it better still equal the same function, which it does, x squared. G prime of x equals x squared.